Top of hour, the doors are closed and we're good to go.
Okay, for our last session, we have just a few things on the agenda. We will begin really quick. Two things for you to check. These are the requests I had for adoptions on Monday. We'll process those. All adoption requests get a pre-adoption uh, uh, shepherd's review. If you're in SR routing, which is what these are, BGPLS, you will get a shepherd's review. I am posting those on the wiki as well as sending them to the email. These will have a shepherd's review. Either they're already this week or they will be there by tomorrow morning. You should respond to the shepherd's review and create. Most people need a revision. After that, it's time to begin the next presentation, Jeff. And I think I can hand it back, close the deck, and let you open the next deck, as the first one is Chang Wang's.
Hi, can you hear me?
I can hear you very well. Thank you very much.
Yeah, thanks. This is Taiwan Ling from H3C, and this draft is about extension BP flow spec version 2 for CAS traffic steering. And our co-authors from China Mobile, Huizhen Yao and Zhengqiang Li. So we see the background. As described in IETF CAS framework, the CAS framework assumed that there might be multiple service instances that are providing one given service, which are running in one or more service sites. The framework defined the following terms, such as CSID, an identifier for a service, CSCID, an identifier for a specific service contact instance. CTC determined which packet belong to a traffic flow for a specific service request. CPS select path towards the service location and instance. Meanwhile, the CAS framework also defined a centralized processing model, and as described in the right diagram, where the service metrics are central collected. Outer central path selection, the result then distributed to the routers. So the flow spec can serve as the controller interface. So our draft extend BPRS version 2 to enable the flow classification and the path selection for CAS. This document expanded on the following scenarios. The first scenario, we redirect the CAS flow with specific flow characters to the corresponding service instance associated with the CSCID. The second scenario, we redirect traffic for a specific service to the corresponding service instance associated with the CSCID by the service ID. The third scenario, we map the flow character to the CSID and then perform the forwarding based on CSID. Let's take a look at the first extension. We redirect the flow to specific CSCID. So we divided two new redirect sub-TLV, redirect IPv4 CS CIID, and redirect IPv6 CS CIID. These two TLV are sub-TLV of the FS version 2 wide community. The second extension, we redirect the flow to CSCID based on CSID. We also define a new field sub-TLV, IPv4 CSID and IPv6 CSID TLV. And these TLV are under the FS version 2 field sub-TLV. The third extension, we define the marker CSID. We define the new marked IPv4 CSID and marked IPv6 CSID action type. These action type are defined under the FlowSpec version 2 wide community. Yeah, that's all. Any questions? Thanks.
Which one, sir? Here?
Hey, Kir Patel, Arcus. I just browsed through the draft, and what I will encourage you to do is fill in the secure error handling section to say what happens if these TLVs are missing. At the same time, what do you do if any other information is present in conjunction with these TLVs? So providing some high-level guidelines to the implementers would be helpful.
Yes, thanks. We will, based on your comment, to revise our draft. Thanks.
G?
Student from Huawei, yeah. As I just mentioned in the chat, there's another draft on the BGP flow spec for CAS of all this kind of metrics. So I'd suggest that maybe the authors can talk to each other and see how to move forward.
And I have overlapping comments to both Kayer and G. From Kayer's perspective, part of what we're dealing with for FlowSpec v2, and Sue certainly can go into more detail than I can at the moment, is we are attempting to figure out how various match criteria, especially for things that may be in addition to traditional IP matching, is going to be encoded in FlowSpec v2. And from the action criteria, we're in the process of working through how we classify the different types of actions and take actions. So the two that are encoded in this draft, one is to actually set the ACS ID so that it gets a certain type of traffic behavior, and also a redirection. So please pay special attention to that work as it's continuing in FlowSpec v2. To G's other point, we have related documents that are sort of fighting for things. I'm looking in the room and trying to see, is Keitan in the room? So Keitan, do you happen to know what the status, or if not, maybe John, of what the CATS working group has in terms of allowing for protocol implementations? Because I thought we were still in the stage where they're working only through requirements.
Yeah, Ketan Talawalikar. So we haven't heard anything yet from CATS. They are working on the metric definitions. I believe it's a working group document now, but we haven't got anything from there. The flow stuff as well, at least I'm not aware of anything specifically. So we'll need to get back on that one, the coordination part between the two working groups.
Okay.
So this needs to be flagged for coordination. Okay, thank you.
Right. And so, Changwan, do you have any further comment?
Yeah, thanks a lot. No comment.
Okay, thank you.
Wang, I will summarize this and post this along with other Shepherd reports for FlowSpec. I mentioned in the first session that I would be trying to collect the Shepherd reports for FlowSpec. It's a little more difficult for FlowSpec as Jeff and I are trying to get some of the big picture things nailed down. So I will keep you in my email thread. And I think we're on to, thank you very much, Chang Wen. And I think we're on to Guyan.
All right.
Yes, thanks.
Hi, my name is Gian Mishra with Verizon, and I'm presenting this draft on 4PE on behalf of co-authors. Next slide.
You have control.
I have control. Okay, thank you. Let's see if I can figure out how to do this. There we go. Okay. All right. So the motivation for the 4PE draft is so there has been a specification that exists for connecting IPv6 islands over an IPv4 core. However, for connecting IPv4 islands over an IPv6 core does not exist to this day. So this draft fills that gap and provides a means of seamlessly connecting IPv4 islands over an IPv6 core. Next slide.
Still you.
Oh, sorry. Whoops. So why is this draft informational? So there are some standards that exist today. So RFC 4798 connects IPv6 islands over an IPv4 core, 6PE, that's been out for quite a number of years. So this draft uses the concept of the IPv6 next hop encoding to carry IPv4 NLRI, documented in RFC 5549 and updated with RFC 8950. So with that, that provides the framework for the next hop encoding to carry the IPv4 NLRI that's being carried over an IPv6 core in this particular draft. And what this does with this draft, we provide the guidance on building those networks and the means and procedures of carrying the NLRI over a IPv6 only core. So just a little recap of 4PE. So 4PE routers exchange IPv4 reachability transparently tunneled over an IPv6 core using multi-protocol BGP, RFC 2545 using the BGP next hop field to convey the IPv6 address of the 4PE router so that the dynamically established IPv6 signaled MPLS LSP can be utilized without explicit tunneling. So automatically tunneling, creating the LSP, and then tunneling the v4 NLRI over the v6 core. 4PE uses RFC 8950, as I mentioned before, for the next hop encoding, 16 or 32 byte next hop. And here are the ingress and egress PEs. What we've done with this specification, as compared to its predecessor with 6PE, we've given a lot of flexibility, and a lot of that's defined in section 8 of the draft, where it talks about really a wide range of permutations for the designer in deploying 4PE, where you have really a lot of a breadth of options of how you want to deploy 4PE. So as well, the 4PE draft, and it is summarized in the draft in further sections, that it is made to be data plane agnostic. So it supports MPLS data plane, SR-MPLS, as well as SRv6 data planes. And then as well, for any inter-AS option, that does support all of the options that exist today, option A, B, C, and AB. So updates to the draft. So we had a chair Shepherd review, and that has been integrated into the draft. So changes, we've clarified the problem being solved with this draft, made clear the 4PE solution. We've simplified the text, plus the SRv6 and SR-MPLS applicability sections, making just overall really clarifying and making clear the exact problem and the solution and what we're trying to solve with this specification. So at this point, we're ready for workgroup adoption, and workgroup adoption is in progress right now. Thank you.
This adoption will continue until April 4th. So as you're on your way home or perhaps looking at things, please take a look at this draft and make your comments. I've provided some questions on the list. Anything else you want to add to this, Kay or Jeff?
So I'll go ahead and add that the document is checked into GitHub and is linked from the data tracker, and that the authors would appreciate that if you have any edits, this is just for clarity, you can contribute there, and you can even open up issues if you don't want to do the text yourself. You have Tobias and Q.
Tobias Siewich, Max Planck Institute for Informatics, and I've been scrolling over the draft, and I was wondering why we need 4 PE. So for context, I've been experimenting with running an AS, which does not have v4 at PE, and that also works, and that is, at least by scrolling over the draft, something that is not discussed within the draft, and the whole issue of working without the discussed tunneling techniques. I'm not sure whether it would make sense to also discuss this or do that in a dedicated draft.
So, your question that you have, if you don't mind, can you take that to the list, I guess, on the adoption call? That would be great, and then we can discuss that on the mailing list. Thank you.
Actually, I was going to say the same. It would be helpful if you take that on the mailing list.
Okay, there are no further questions in room and nothing in the queue.
Thank you
very much.
Thank you.
Sri Hari. There you are.
Hello, folks. This is a presentation on BGP dynamic capability. I'm presenting this on behalf of Ankit Chan, who is not able to join here. Okay, so what I would like to cover here is give an idea of what has happened on this draft. It's a long history, and then sort of briefly cover the problem, recapping the problem and the solution, and then talk about specifically about what changes are we trying to bring in. And then I would like to get feedback either now or on the mailing list. Okay, so this draft has been around for a while. It got published in the first place in early 2001, then adopted by IDR. A lot of discussions have happened, a lot of comments, and thanks folks for providing comments. We did try to incorporate some, but some point of time, I think there was a sort of a silent period and we have not been able to sort of update the draft, and now we've picked it up. So we're gonna try and collect all the feedback and give this draft updated and then go back, right? So in the meantime, there have been a lot of implementations. I've listed some, there may be more. And then let's try and get this draft fixed correctly. Okay, so what are we trying to solve? This particular draft helps in enabling any capability dynamically. And that means today we have optional parameter in the open message that a BGP speaker can use to advertise all the capabilities that it can. And likewise, after the establishment of the session, then the two peers can figure out how to use the capabilities and then whether it is applicable to a simple route refresh or a scalar kind of capability or address family, which is called as a multi-instance. All of them are being done today. But this, with the lack of dynamic capability, we know it's going to be a major problem that sessions have to be reset for us to enable any new capabilities. Right? So looking at the capabilities since the last, I'd say, 20 plus years, we have come up with many capabilities, and then I've classified them into these three. One, which I call as a type A, are typically the capabilities that does not require both the coordination between the two speakers. If you go by the definition of the capability, which is the RFC 4760, a speaker can say, I'm capable of ABC, and it's up to the remote speaker to advertise its capability, and then the local speaker can determine, am I okay with it? Can I go ahead with the session or not? So there's always this difference of capabilities between two speakers always can exist, and the local speaker can figure out whether to continue the session or not. But if you look at the capabilities, AFI-SAFI is considered as a one capability which can list multiple address families within it. So, but still you can continue the conversation without a tight coupling between the two. So those capabilities I'm considering as type A. The more simpler capabilities are like route refresh or GR value, where you need to refresh with the GR with a specific value, calling it as type B. The type C are a little more involved, where you need more tighter coordination, tighter coupling. Take, for example, add path. After the capability has been exchanged and agreed upon, the structure of the message changes. So in which case, it's more important for both the speakers to understand, when am I really going to use the new structure, right? So with this, what the current draft, which is the 16, what it does today is we have the type code 6. That is the new message, the capability message that it introduces. And then the way the operation is described in the draft is, in the open message, like any other capability, you advertise that I am capable of dynamic capability refresh. So that's one. And during the lifetime of a session, a BGP speaker can send this capability message listing a revision, either adding or withdrawing a capability. And we have the capability message talking about what is the action, add or remove, specific capability. And then you can ask for a acknowledgement. It's an optional. And then there's a sequence number. So it's all defined there, which typically has been good so far. With some implementations, route refresh can easily make it work. Address families are a little bit more complicated because there are some ambiguities that are there that has made implementation of this a bit more difficult, and some people have backed off from implementing the address family. But today, most of the implementations are out there, do have route refresh and GR. GR has been a predominant usage of this version of the document. Right now, in the next set of slides, I'm going to talk to you about where are we finding problems in this current version. Okay, let's look at this. Let's talk about the major issue. Major issue is this particular diagram talks about, let's say the initiator is the BGP speaker, which starts off saying, I am now revising one of my capabilities. Either I'm adding a new capability or withdrawing a already revised, a capability that I've already talked about, either in open message or in one of the prior dynamic capability message. And the receiver is the BGP speaker who is assisting this capability revision. So what in the current 16 version, let's take add path. That is more easier to explain. In case of add path, after the receiver acknowledging the capability refresh, it comes to the initiator. When the capability ACK has been received, the initiator can now send an add path with a different format, which can say, this is my path ID, right? Now, whether it sends a path ID based message, which is the add path update, prior to receiving acknowledgement or after receiving acknowledgement, has not been clearly spelled out in the draft, which makes the receiver in an ambiguous state as to how do I interpret this. So this is a major issue that 16 version the document does not address, and I'm gonna call it out here. There's an ambiguity in the receiver. The other set of issues are less severity. Like for example, we say the initiator sends a capability revision and the acknowledgement is optional. And when we did this in the early days, we thought we could just do let's say route refresh. I'm going to tell the remote speaker that I'm now route refresh capable. So the moment the receiver sends me route refresh request, I can just act upon. So I don't need to wait for any acknowledgement for that. The sending of the route refresh request itself can be an acknowledgement. So in that sense, ACK was optional. But then if ACK is optional, now we do not know whether the remote speaker is sending me address family messages, let's say Office updates. Should I consider that as a drop or a silent discard, or should I accept it? Me being the initiator is not very clear. So some of these things are ambiguous, which makes the initiator get into confusion state. So and also in the draft, the text is little condensed, and therefore sometimes people have come up with questions as to, are we talking about a specific Office capability, or are we talking about dynamic capability, which is also another capability that this document is introducing. So we want to clarify these aspects in the next updated version. So what am I trying to bring in the 17th version? And I couldn't post it. Maybe it'll get posted, maybe in later in the day or something like that. So what we're trying to do in this current version is, in the 17th version, is we're trying to limit the scope of what the dynamic capability refresh can do. So we're going to say do only type A and type B. Type B is more easier. Take GR value or take route refresh, which is a scalar kind of capabilities you can refresh. In case of type A, you can advertise or you can revise a capability. Let's say take multi-instance capability of Office AFI. You can say, rather than saying I'm going to enable the multi-protocol extensions, you have to say specifically which Office AFI am I enabling. So therefore, you have a granularity of the multi-instance capability instance that you will have to either add or remove at that one granularity level. That's one. Second thing is we are forcing acknowledgement request from the receiver. So this will help remove the ambiguity on the receiver as to when should I send messages, and also the initiator as to how should I interpret the incoming messages. Sequence number is good, but then we introduce sequence number in the original draft to make sure that we can correlate the incoming acknowledgements, especially when the initiator is sending and receiving, or adding and removing the capabilities in a sequential manner. How am I going to interpret the acknowledgement? Maybe a sequence number will help. But then we can also determine from the capability content. So in the current version, what we are proposing is sequence number is still needed, maybe for a troubleshooting purpose. You don't have to necessarily match on that. But I'm open for any feedback on that as to how we can improve. And specifically, the limitations is type C capabilities, which is add path kind of capability, should not be used in the current 17th version of the proposal. That's a limitation. Right. Specifically for the multi-instance, the address family capability, here is some more additional text. But basically what I'm trying to say is there are specific time instances where what should the initiator and how should the initiator treat the incoming messages before getting the acknowledgement back from the receiver. You should continue to operate in the current state. Let's say you have already advertised Office AFI, continue to behave and stick to that when you send a revision of withdrawal. So if you're removing a capability, then continue to accept messages until you receive an acknowledgement back from the receiver. Once the acknowledgement is received, then from then onwards, any messages that you receive from the receiver, you can silently discard. Right? That's one. And likewise, if you're advertising new capability, then once you receive an acknowledgement back from the receiver, then you can start accepting any updates for that Office AFI from the receiver. So just this slide talks a little bit more specifics of this behavior. So we believe the current version of 17, I'll be glad to sort of receive any feedback, should address both type A and type B capabilities. For the type C, this is a new draft that, again, it's pending into the queue. Couldn't figure out what the problem was from when I tried to post it. This pretty much copies a similar mechanism of initiator and the receiver trying to send the dynamic capability message types. But because we are introducing stricter procedures, we are proposing a new capability called extended or enhanced dynamic capability, where we are introducing new subtypes, ACK confirm and NAC. ACK confirm is the initiator sends a capability revision the receiver acknowledges back with an ACK, and the initiator sends the ACK confirm, so that the receiver knows that whatever that he has acknowledged has been heard and the initiator has acknowledged. This is primarily useful when, take an example of add path. The receiver has seen the initiator saying, I am now add path capable. So receiver sees it, receiver acknowledges back, and at that point of time, the initiator cannot send a new update path with the path ID. It has to let the receiver know that from now on, I'm going to send you the path ID with the updated structures change. So the ACK confirm will help confirm the receiver that once I receive ACK confirm, from then onwards, I can start interpreting in the new structure. And likewise, there may be some cases where the receiver may have to knack some of the capability revisions just to keep the conversation more stricter and remove the periods of ambiguity. Right. So effectively, this sort of helps between two speakers who are trying to negotiate, and both of them have to have the same capability enabled. Type C, this particular draft addresses that. This draft addresses not just type C, but also type A and type B. So we could just move on towards using enhanced dynamic capability only, but unfortunately, we have a lot of deployments. We have to figure out how to handle both the deployment as well as how do we move forward, right? Okay. Now, I do have slides more in the backup, but I've let people ask questions and we can talk about it. There are already people stand in the line. So what I'm requesting IDR community is, one, look at the 17 version. Provide comments. We do have a message type 6 that we are using, but we have to make sure that it is updated in the IANA that we can get done. Error code is another thing that we should get it corrected. And for the new enhanced dynamic capabilities, look for any feedback from the IDR community on this. So, questions?
So Krishnaswamy, Cisco. So can you go back to the slide, where you have ACK is a must?
Yes.
Okay. So have you looked at both? Now I think, type C, you're taking it out, right? Type A and B. So is ACK is a must for type B?
For type B, which is typically, let's say, route refresh, ACK is not a must.
Okay.
But we want to have a consistent behavior between the two. In fact, if you look at the first draft, which is the latest, the 16 version, ACK is optional, primarily with the intention when we did this in the earlier days of 2000s, keeping it simple was the way to go. And route refresh, you don't need an ACK. Just the fact that you're sending a route refresh request itself knows that a receiver has seen my capability refresh, right? But to keep things consistent and simple, we thought making ACK mandatory would help with just one additional message, and that way the initiator can always have a consistent behavior, is the current thinking.
Yeah, see, the people who have implemented 16, the version draft, right? So where it is not a mandatory.
Yes.
Now, later, if someone implements 17, now there is an interoperability issue. So have you spoken to you have listed down the list of vendors, right? So have you spoken to them and got the feedback that, hey, by changing this to a must, is there an issue?
Now, it's a good question.
This,
yeah, thanks, Krishna. So it's a good question. Now, if you look at the 16, I've talked about it, but I don't think it's there in this deck, but I have it in the draft that you'll see. The specifically talked about a section for deployment, backward compatibility. Let's take about the example, right? Let's say we have a deployed, which is 16 version, which does not, which can respond to a initiator asking for a acknowledgement. It can, because the 16 version says ACK, look at the ACK request bit. If the bit is set, then you respond. If the ACK bit is not set, then you don't respond. This is the 16 version. This is the deployed base. Let's say the initiator is new. Initiator is saying, initiator is always setting the ACK request to 1, which means it is always expecting the receiver to respond. So the 16 version, which is deployed base, will respond with the acknowledgement. So there is no interoperability for a new initiator and an old receiver. Let's take it the opposite. old initiator and a new receiver. Old initiator tries to send a capability revision with the ACK request bit set to 0. That means the new receiver will honor back, because it's just going to say I'm not supposed to respond and send back with acknowledgement, so it's going to sit quiet, right? So which means there is no interoperability issue for a route refresh or a GR value negotiation today. When the new initiator, old receiver, or an old initiator, the new receiver, there is no interoperability issue. But where the problem will happen is if the new initiator or if the old initiator, if it does not get acknowledgement back, because he's not going to expect for acknowledgement, and if he's trying to do a AFI-SAFI revision, then there is a moment of ambiguity. So in that sense, in summary, there is no interoperability issue between this, old and new initiators, for example. But at the same time, to get the things correctly working, it's advisable to have people upgrade the routers to have the new implementation.
If you reverse the the analogy what you gave, right? The 16th version implementer is never going to set the ACK request at all.
Yes.
But the 17th version is mandating it.
Yes. Right. So which means that's the case.
Must, right? So then how do we interrupt?
Exactly. I'm going to say. So let's say old initiator and a new receiver.
Sure.
Right. Old initiator let's take about case for type B who is trying to send a GR value revision. Right. Old initiator sends the capability request with ACK request set to 0.
Yeah.
And he's revising GR value. The new receiver sees that ACK request is 0, so therefore they will not respond with an acknowledgement.
Okay.
Right? And then they're going to see the GR value, they're going to act upon it. Right?
No, but here, sorry to cut you through, but here it said it's a must. It should be always set.
That's the new initiator. I'm talking about the old initiator and the new receiver.
Okay, but at least it's not mentioned that it's a new initiator, right? Like it's just a BGP speaker who is sending this capability, and you say must. So there are already implementations. They are not going to do it. So that's like contradicting.
Right. But Krishna, this is for 17 version. So when I say initiator, I'm assuming this is a new initiator.
No, because once it becomes RFC, nobody is going to look at what is 16 and what is 17, right? Like they just look at it. Oh, it's a must.
Right.
So what happens to the already deployed code? So that's the reason I asked. Like have you talked to all the vendors and collected like whether making this change? So definitely this is something we have to get it corrected. Otherwise it is going to break the deployment.
Yes, we can definitely go pull the existing deployment and try and get how they handle, because I don't think everybody has implemented using this for solving capability revisions for all capabilities. As we know, there have been some problems that people have found, but I take your feedback, collect the implementation report. That's a good thing. And I think once the draft is posted, I would encourage you to look at the section where I talked about the deployment interaction. And then if you have any comments, I'll definitely be happy to take the feedback and then incorporate.
Okay. So that's on the backward compatibility. Then probably we can take it in the mailing list also, but I'll just make a statement here. So for GR thing, we don't really need an ACK, because I'm just publishing what is my GR timers, and the other the BGP speaker receiving is just going to it. So it's not this. We should really relook into it to making it mandatory. Rather, let the optional capability dictate whether it requires an ACK. Then it can set it. If it the optional capability like GR timers, it does not dictate that it requires a response from the peer, then it should set it. So I think we should definitely look at this.
Sure. I'll take the feedback and then discuss it and come back.
Yeah. Thanks.
Keyur Patel Arkas, really simple question.
Sure.
Hopefully should be straightforward. The new capability, I'm assuming there will be some text, or would you add some text where it says it covers a subset of old capability, plus it does additional stuff, so that newer implementations don't have to implement both.
Sure.
It could be a nice transitional way of moving to the newer capability. Yeah.
We'll do that. Yeah. Thanks.
So Jeff it's lovely being last and being chair, because people have made most of your points for you by this point. I'm going to repeat a comment from Tony P. BGP is a Swiss Army knife. It doesn't have a handle. It's all knives. Unfortunately, the problem we've always had with this feature, having dealt with this, is that the edge cases are everywhere. So this is going to be very challenging. And the 2 points that I'm holding on to the most is, as you're pointing out, we have code that's actually shipping some useful things for this at the current 16. And IETF does have a sad tradition occasionally that you have to codify and just say, this is shipped. We're going to have a cut point here, include the procedure somewhere. You could leave it dead, and we can figure out exactly how we want to do it. And as Chung Wang was pointing out on the chat, we probably should just simply take the enhanced item and put it into the current draft as, this is what we're doing from this point forward.
Sure.
But let's go ahead and get a little sense about what we're doing there first. But I think we're actually at a freeze point where we just simply document what's shipped and then get ourselves to, how do we solve all these edge case problems?
Sounds good.
Okay, so I'm going to encourage the rest of the working group, please read through this. This is full of edge cases. And, like the ability to say no, the NACA element, sort of scares me personally. So it'll be interesting to see how we can work this stuff through and just get all the state machines to agree.
Cool.
Thank you, Sherry.
All right. Thank you, guys.
Isong?
Hello, everyone. I'm Isong Liu from China Mobile, and I will be on behalf of my co-authors to present the SRV6 segment list optimization. For the background, as we know, there are two scenarios to use the end seed of the egress node in the seed list of the SRV6 policy. One is that steering the traffic based on the binding seed. The other one is that when we use the OEM to detect the end-to-end SRV6 policy, so the end seed of the egress node is also used. So this may induce that the data packets may be encapsulate both of the end seed and the service seed in the seed list. And the result of this may have some issues in the following. One is that the PSP behavior may not be feasible because they may not be feasible because the condition is not met. Which means the penultimate endpoint node cannot remove the SRH because the segment left is not equal to the 0. So, the second issue is that for the forwarding efficiency of the egress node, because the egress node will need to look up the seed table twice, local seed table twice. For the certain chips, it maybe requires a loop back. That may be very impact the forwarding efficiency. So in this chapter, we provide a proposal, and both the end seed and the service seed of the egress node are present, and the controller can notify the ingress node that whether the seed of the egress node is included. And the ingress node may optimize how to encapsulate the seed list. One encapsulate for the data packets, the end seed will be removed. When used for the OEM, like the UM packets, we will use the end seed of the egress node. And this is the protection protocol extension for this proposal, and we use we use the administrative flag for the candidate parts. That if the flag did in the reference draft draft link, we use the N flag to indicate that the egress node seed if or if not in the seed list. If set one, it must include the and seed of the must include the seed of the egress node. So for the example, one for the data packets forwarding to one VPN, this we use the VPN seed for the egress node for the P2. P2 have two seed. One is that the end seed is Y5:5, and the other is the VPN seed for the 5:100, and we can use the BGP with the candidate path with the N flag to notify the ingress node, and so we when for the data packets forwarded to the VPN, we use the VPN seed, and for the OEM packets, we use the end seed of the P2. So this draft has presented at the IETF 117 and the interim IDR. We have updated the draft based defined the flag on the candidate parts. Replace the original draft. We use the type the seed flag in the seed level. So thank you to Jeffers' comments. So during the last presentation in the interim meeting, so the Supreme Chair requests us to conduct a requirements survey. So we will receive the positive feedback we can in this link, and additionally we have to resolve this problem. We mentioned problem. Similar BGPRS and PCP drafts were also submitted and presented. So we co-authors think we would like to ask for the working group adoption. Thank you.
So for Cisco Systems, thank you. Just want to point out some discussion that happened on this topic in last IDR meeting, and after that, the overall thing that I start doing is that write a draft in spring that list the core components, so that the spring can have this discussion, and then protocol component, PSAP, BGPLS, and BGPT API can happen in the individual working group. So we're working together, like you are co-author on the other draft, so we're working together. So I think let's plan that way. And so that's point one. The point two that I like to mention is you have a dependency, and that applies to this draft, on the administrative flag TLV, which is not, as far as I know, it's not a working group document. So there is a dependency there as well. Okay.
Yeah, I see that. Thank you.
Thank you.
Here.
Hey, K. Patel Arcus. I got a curious question. What happens when controller signals this flag, but implementation on the other side doesn't understand it? Do you run into issues, or can you put some text in the draft just talking about it?
And the feature is not supported by the local network completely, how does it behave? You can answer the list.
Yeah.
Oh, yeah,
You
yeah.
can take it.
I was thinking that.
So just repeating the question to the author, how does this behave when it's incompletely supported by the network? He will answer on the mailing list.
Thank you.
There are two more questions. Andrew?
Oh,
Andrew Stone, Nokia.
sorry.
I just did a quick skim just to see for the TLVs. It feels weird to go in the admin TLV, but I can see why you did it because when I was trying to look at the TLVs, where else could you put it? It's not really obvious. And then at the same time, I took a look at the BGPLS and I took it to PCE. They're all in different TLVs under the candidate path. So the state has a TLV that it can put it into. The PSEP1 actually defines a new TLV, and for the BGP deployment, it's using the admin. I would just kind of ask that maybe all the authors for all the different protocols maybe figure out if there's a way to have a common TLV where to put this flag, just so that way we're like a common definition of a TLV. So that way it's not like in one protocol, it's under one section of a TLV, and in a different protocol, it's under a different one. Just something to consider. Thanks.
Thank you. Very quickly, last question.
Very quickly. So just for Kayur, and I cannot answer for this draft, but for PSEP, there is a capability exchange between the peers before this message can take effect, this kind of action. But that's PSEP. I cannot answer for this.
Yeah, we need some text in this document because I don't think BGP will read into PSEP capabilities.
So thank you, Yusong. We need to move to the next presentation. Thank you.
Thank you.
Okay. Hello.
Hello, Jimmy. We can hear you. I'm going to pass the slide control.
Yeah, thank you. Hello, this is Jimmy from China Mobile. On behalf of my co-authors, my presentation today is called PGP-LS Advertisement of Q. Currently, the path computation mechanism for SRv6 in the network are typically based on the delay or bandwidth. For delay, operators usually provide users with deliver guarantee within a certain delay range and seek paths that meet the condition accordingly. Regarding bandwidth, the common practice for operators is to search for paths in the network that can meet users' bandwidth requirements based on their demands and use some rate limiting measure to ensure that a user does not exceed their allocated bandwidth. However, with the deployment of AI-related service, especially various enterprise computing intensive businesses, the traffic model has changed. User traffic has gradually shifted from being relatively smooth to periodic bursts, and burst traffic exceeding the speed limit often cannot be guaranteed. Fortunately, in Q's technology, there are relevant parameters for traffic monitoring and bandwidth guarantee named CIR and PIR. These two parameters can be used on a network device to achieve commitments for to forwarding rates as well as burst guarantee and control. To address the above mentioned problem of a user service traffic burst, and we propose a solution that combines the resources guarantee of SRv6 policy and Q technology. When the controller calculates the path, it's based on the CR and PIR resources conditions on network devices rather than the interface bandwidth. The CIR is used to ensure the user traffic forwarding for most of the time, while the PIR is used to ensure the forwarding of burst traffic. The PIR part can be shared. When there is a conflict in the shared bandwidth, the device's buffer space is used to buffer the traffic, and the configured CIR and PIR should satisfy the following constraint relationships: the sum of the configured queue on the interface and their CIR val should be less than or equal to the interface bandwidth. the sum of the differences between all PIR and CIRs multiplied by the burst time should be less than the buffer size of the chip. Based on this principle, the lower limits of users' bandwidth requirements can be guaranteed by CIR, and the burst requirements can be shared by PIR. Moreover, within the committed burst time, the chip can buffer also. The chip buffer can also be used as a guarantee for user traffic during port congestion. So this draft is mainly proposed 2 draft extensions to report the queue. One is the QLRI, which is used to carry the queue number, and the other is the queue attribute description, which is used to carry information such as the configurable CRN and PIR values of the device. In this 0.0 draft, only queue length and queue depths are written. We plan to update CR and PR in the next version. So in general, we have proposed a method for SRA6 path calculation based on the CR and PR values of device. This draft is part of its resource reporting. The reporting frequency should not be very frequent, and it will not change the current BGP LS mechanism. It only uses BGP LS to report device queue resources. The content of this presentation is just a simple idea after we discover some problem in network operation. And we think it's still a lot of work and needs to be improved. So the next step is to absorb suggestion from the WG and I think that's all. Thank you.
Okay, thank you. In the queue, first up we have Arvind.
Hi, Arvind from Cisco. I just want to highlight the fact that BGPLS actually don't guarantee you the timely delivery. Also, just to consider whether or to check whether we have considered the NPOs which support dynamic queuing here. Just wanted to check. Yeah, thank you.
Okay, thank you.
Andrew?
Andrew Stone, Nokia. Is my understanding correct that there's no intention to actually put this in IGP and that you would just inject directly into BGPLS?
Because this is IDR working group, we're just list the BGPLS extension.
Okay, because what I was curious about is if it was intended to only be BGPLS. The nice thing about LS with the topology was that you wouldn't have to have sessions to every router in the network, and you just suck up the IGP from a few speakers. So it might be worth considering that if you wanted to collect this network wide, you now need to have LS running on every node sharing that information. So it might be worth just kind of commenting on that. Thanks.
Okay, thank you.
I have a comment from G, then I have one myself.
Yeah, Jason from Huawei. I think you are trying to advertise information which may change at a different frequency, right? Something may be relatively static and something can change very dynamically. Maybe we need to consider whether it is proper approach to put them into the same protocol extension, or we can think about whether using different approach for this to kind of information.
Okay, thank you.
And my comment, I think, is the final one. So to Andrew's point specifically about, is this only in BGPLS? A useful thing about BGPLS is it doesn't have to have everything that's the IGP, and of course, vice versa. And clearly, we want to coordinate that when there's overlap. But one of the things that is attractive about LS is that all the dump truck things, as some people like to say, about wanting to put stuff into the IGP, it doesn't have to go there, can go into BGPLS. So I think we're going to start seeing over time this be more common.
Yeah, I totally agree. I also then wonder if you're going to create sessions to every node to just get this. maybe gRPC or netconf would be another way to just
telemetry using.
Yeah, I completely agree. So thank you for the presentation, and you are the last presentation of IDR. Thank you very much.
Okay, thank you, Jeff.
So two quick things. If you have not signed in, please do so before you wander out the room, so we make sure you have a bit of space. This is a good point to give our thanks to Jidong, who has actually done a wonderful job, as always, about coordinating the very large number of presentations we have. And Sue, did you have any parting comments?
No, just safe travels to everyone who's remote in Bangkok.
Okay, Kair.
See you at the next IETF.
See you in Madrid. Have a good day.